Let's explore an intriguing theory that ancient civilizations may have harnessed atmospheric energy to power their cities. With advanced materials like piezoelectric bricks, tall architectural spires, vast water systems, massive pipe organs and bells, they might have built self-sustaining energy grids. The Earth's atmosphere naturally holds electrical energy, stemming from the atmospheric voltage gradient. This gradient arises because the Earth's surface is negatively charged, while the atmosphere is positively charged. As elevation increases, so does the potential voltage, about 100 volts per meter. Cathedrals with tall spires and conductive designs could act as antennas, drawing this energy down into the structure. Now, let's dive deeper into piezoelectricity, nature's energy converter. The name comes from the Greek word piezein, meaning to press. One of the most common types of piezoelectric materials is quartz. When these types of materials are deformed from pressure, vibration and friction, it will generate electricity within the material. Remarkably, the reverse is also true. Applying an electric field also causes these materials to deform. However, in this instance, the energy is stored as electrical potential. This ability to convert energy between both mechanical and electrical forms makes piezoelectric materials very unique. It's the perfect building material for a structure intended to harvest and store energy. In cathedrals, piezoelectric bricks potentially made from quartz-rich materials could have played a central role. Tall spires collected atmospheric energy, creating electric fields that energized the bricks. But the real magic happened when pipe organs and bells filled the structure with sound. These vibrations exerted mechanical pressure on the bricks, amplifying their energy output. The combined resonance of atmospheric electric fields and sound vibrations created a compounding effect, generating even more energy. Now let's explore how this energy could have been transferred to saltwater canals and waterways, which stored and distributed power. Salt water, a natural electrolyte, conducts electricity due to the ions dissolved within it. These waterways often acted as conductive channels and energy reservoirs. Now imagine the energized water rushing through channels, pushing against piezoelectric bricks embedded in the canal walls. The constant movement of water provided a steady source of mechanical stress on the bricks, converting the motion into additional electrical energy. These waterways could have stored energy captured from atmospheric sources, whilst additionally generating even more energy, and creating a distributed power grid across the city. By now you're probably thinking, with everything in a city being highly electrified, wouldn't it cause major safety concerns? An energized city does sound dangerous, but ancient engineers likely understood the risks, using careful design to protect inhabitants. Power structures and waterways would have used insulating materials and grounding systems, allowing excess energy to safely discharge into the earth. It's also important to understand that current, the flow of electricity, is dangerous, but not so much the voltage. The low current of atmospheric energy would ensure that while voltage was high, the risk of harmful shocks remained low. Applications requiring high current could easily store up energy and facilitate high amperage discharges using insulated structures. Interestingly, the electric fields created and stored by piezoelectric materials might not have been purely practical. They could have had health benefits. Small, controlled exposures to these fields, combined with the resonant sounds of bells and pipe organs, might have been seen as spiritually or physically invigorating, much like modern electrotherapy. We're starting to understand the technology of the ancient world. Their systems were simple yet highly effective. Do you think we can rebuild a world like this? There is so much evidence of a golden era in our not so distant past. Let's continue to learn together, and maybe we can rebuild another golden age. It's such a fascinating time to be alive.